Hi, in this video, I will show you how to build, train and deploy a machine learning model with using Amazon SageMaker. As you see in this picture, this is just my banner of my demo. Here, I will focus more on how you can leverage Amazon given machine learning service that is SageMaker to build, train and deploy a machine learning model. All right. So here, let me take you to the my AWS account. So as you see, this is my AWS account. I am currently in Ireland region. Here, what I do is I will create an instance of Amazon SageMaker, and from there, I will help you to walk you through the complete steps that we need to follow to build an example machine learning model, and also we deploy that machine learning model. Finally, we also evaluate the performance of the particular machine learning model. All right. So for that case, what I did is I have noted down all the steps that we need to follow in the form of a Python file, and this file will be shared in the my GitHub repo, and the GitHub repo link will be shared in this video's description. Please find this file from the GitHub repo and try to follow the steps that I'm going to show you here. And yes, eventually at the end of this video you will experience like how to build, train and deploy an example machine learning model. Yeah. So here we are extensively using the Amazon SageMaker. That's a very important point. Yeah. All right. So here, first of all, what I do is I follow two steps. Okay. All right. First of all, the steps that I need to follow, I have documented very clearly in this script, in this Python file. This is a Python file. We will follow the steps in the order. All right. And parallelly, what I do is I will just create an Amazon SageMaker instance first. Yeah. Then we will follow the steps which we are supposed to follow from the scripts. All right. So, okay, so first let me create an Amazon SageMaker instance first by clicking on the create notebook. Yeah. So here what I do is I give a name of my SageMaker notebook instance, something like that. Yeah. For example, I will just give like, my SageMaker CQPOCs, which is my channel name. Yeah. CQPOCs. All right. So this is the notebook instance name which I need to give. Okay. So here, you see here we are in the Amazon SageMaker, and in that one SageMaker, we are creating a notebook instance. Yeah. And while creating a notebook instances, it will ask for certain details. For example, notebook instance name, and this is why I'm giving it. And finally, a notebook instance type. As you might be knowing, like while creating the AWS EC2 instances, we give the instance type, right? Similarly, here in a notebook instance is nothing but underlying and a big, you can call it as a very big and fully flexed and dedicated for doing a machine learning workshops. Okay, such instances we call it as a notebook instances, we can call it. So that's the reason here you see the name is notebook instances. Okay. All right. So here we are choosing the default type, that is ml.t2.medium, and the elastic references, let keep it none. And after that, platform identifier, let it keep it by default, whatever been given. Finally, in the permissions and encryptions, okay, so the by default it will tell you like to choose your existing IAM role, or else let us create our own IAM role. So and here, since it's an example, I will just let a SageMaker instance to create its own IAM role, which is needed to process its own jobs. Yeah. All right. So let me keep it by default, and I will go ahead and keep the other options. For example, network, GitHub repositories and tags. Let it, since these are all optional, I will just keep it optional. Whereas in the production environment, probably you might need to use these options. Yeah. So here I go ahead and create a notebook instances. Okay. So I just create. All right. So this is very lengthy process. You see the status of my notebook instance, which is a SageMaker notebook instance, is currently in pending state. It takes nearby 3 minutes. Yeah. While this notebook instance gets created, I will just walk you through the steps that we will follow in the next couple of minutes. Okay. All right. So so here you see it contains, so in the sense this tutorial, in this tutorial I will be showing you, majorly these steps. Okay. First one, you see the step one, which is creating Amazon SageMaker notebook instance for data preparation purpose, which we have done just now, and it is in progress. Now after that, we have to go for the prepare the data, in the sense data while working with the machine learning models, we have to have the data preparations. Okay. That becomes a second step. Yeah. And I go to the next one. So in the next step, okay, so the step number 3, you see, so next one, we will use the we will use the above data to train our model. Yeah. That is a machine learning model. Yeah. So here again, so let me tell you one explicit thing that here we are using the XGBoost machine learning algorithm to build our model. Yeah. Okay, so then in this case, this is the this is the steps where we will be training our machine learning model. Yeah. And finally, we deploy the about trained model into the example machine learning instance, and okay, once we deploy it, it will expose you an endpoint, and that endpoint, with using that endpoint, we will do a evaluation of the particular machine learning model. Okay. Alright, so these are the majorly 5 steps that we need to carry out to experience it, like how to build, train, deploy, and evaluate a machine learning model. Okay. So here, the person who is performing this, these steps are nothing but we will call him a machine learning developer. In the sense, machine learning model developer who is using the Python morely to develop those machine learning models. And also this model, this model is an example model, where with using this model, what we do is we perform the a kind of evaluation on a particular bank applications. Okay, let's say there is a bank product is been getting released, and on top, before the product is getting released, what he is doing is that bank is particularly performing a prediction on the particular particular product. In the sense, the bank itself running this machine learning model, and it is forefront, it is predicting, like how does that product can behave in the market. Okay, so that is kind of that is how the technology is growing now. It is now replacing the astrologers. Okay, so in good old traditional days, we used to have some very insightful persons who used to sit in the room and tell us about some predictions. Okay, which we call it as astrologers. But now we have the machine learning, which you will which works on a real time data. It does multiple calculations, and at the end it will give some predictions data, which will be almost like equivalent to the future predictions. Okay, so that is how the technology capabilities, and that is what machine learning model helps us to do this. Okay, so here we are working on a prediction algorithms, yeah, predictions machine learning models. All right, so here let me go back to the our notebook instance creation steps. As you see here, it's still in progress. Okay, you have to be patient because it takes nearby 3-4 minutes. And finally, once the status changes to the online, then we have to go for the next steps. All right, so while it is again in progress, I will just walk you through these steps one more time. So here in the preparation data, so in the first step, what we do is we import the libraries. In the sense, in the notebook instance, I will tell you the further steps after that, once the that notebook instance comes online. So first, in that notebook instance, we run certain code, and the code is something like this. Okay, you see, right? So this is a big code. Probably you have to copy this much and put it into the notebook instance code space and run this particular code, and eventually what it does is it imports the required libraries and defines the environmental variables. Okay, so let me go back. I can check the what is the status of the particular instance. It is still in progress. So while that is in progress, let me walk you through the what actually this import libraries and define the environmental variable does. Yeah, nothing. It is just an example Python code. Okay, so if you are a Python developer, definitely you will understand this code very quickly. Okay, so but let me help you to understand this code. Okay, so here we are importing multiple libraries. When I say Python libraries, when I say libraries, nothing but Python libraries. Here it is importing the Boto3 model, which is a AWS SDK. It is using the RE. I don't know what is RE, but yes, it is importing this one. Then we have the sys module. Then we have the math module. Again, so machine learning models are nothing but it kind of a data flow. If I want to understand, or if I want to help you, like what is the machine learning model, is that nothing but it's a kind of you can call it as a flow of the data. If the data flows through particular chart or particular algorithm, then at the eventually we will have some result, and that result will help us to understand how does your particular product can work, how does your particular service works. Okay, forefront. Okay, before you release something to the market, you want to analyze like how does that product can perform for you. So that kind of prediction can be done when you run the particular a particular data set that you have on your services, and just give that input to this particular machine learning model. At the end, we will get an output which is nothing but which will help us to understand how does particular services or particular product can perform in the market. Yeah. All right, so let me see the status of the instance. It is still in progress. All right, so let's quickly walk you through this this code, which is actually imports the libraries. So okay, here as I say now, mathematics. Okay, mathematics is the something like which is heavily used for doing the or building a machine learning algorithms or machine learning models here. All right, here we will be using the JSON OS. SageMaker is again a kind of library we are using. Then we have the URL lib.request as well. And from here we are also importing the multiple sub modules as well. Here get execution role and get the SageMaker from that. And after that NumberPy as some NP and pandas as PD. Then we also have the MATLAB matplot library that Python plot, where we will use the PLT as that one. Similarly we are using the image display, and from the time we are also we are importing the time from the GM time and start time. Okay, start F time as well. All right, there are a couple of these are, you see, there are multiple libraries are being consumed here, and those libraries will be used by our machine learning model which we are going to build here now. All right, the first one after that what we are doing is it is defining a role. You see, get execution role. Okay, so this is a function, you see, from the SageMaker, which will this is a function within the SageMaker module, and once we invoke that function we will get a role, and that role will be consumed down the line. Yeah. All right, so now and after that prefix, this is the prefix, and after that you see, right, my reason. So this will set the reason of the instance. You see, we are using the Boto3 model, getting the session, and after that inside the session we are getting the reason name. Yeah. And after that we are having here, that's what I said. Okay, so here we are using the SageMaker model, then image URIs, and after that retrieve the XGBoost. Okay, as I said, we are using the XGBoost machine learning algorithm to build this module. Yeah. And we are using the my reason, so the reason which is the which is the reason where the SageMaker instance is up and running fine. Yeah. And finally it prints something else. Okay, all right, so this is something like machine learning developers job. They will write this code, and eventually they will use this piece of code and run it at the Amazon SageMaker instance. I will show you like how does it behaves. Here you go, right? Here you go, you see our SageMaker notebook instance is up and running fine. Yeah. So once you see the status of your notebook instance is in service, then yes, we are good to go ahead. And let's click on the link called open Jupyter. Okay, if you open the Jupyter, it will redirect us to next tab, and this is where we see we see the next workspace where we can leverage that workspace to do our next jobs. Okay, so it will take some time. We are redirecting you to a notebook instances. Okay, so it is again doing a multiple redirection. Eventually we will go to a Jupyter page. You see, this is a Jupyter page. From here we can leverage our next steps. All right, so what I did, I went here and I click on the open Jupyter. Okay, so now the Jupyter homepage has been opened. Okay, so Jupyter is a nothing but kind of an interface through which you can run your machine learning code, you can say, I can say. Yeah. All right, so here next step is in the, you see there is a button called new. Inside this new, what we do is we leverage Conda Python. Okay, you see there is a Conda underscore Python module. So okay, I will click on that. So what I am doing is I am using the new version of that one, and where I'm clicking on a Conda underscore Python 3 kind of thing. So you see I'm being redirected to the next next tab where I can leverage and run my Python code. Yeah. All right, so you see I'm in a Conda underscore Python 3. You see I'm in Conda underscore Python 3 interface, and here I can run my piece of code which through which I can through which I will be building my machine learning module, I can say. Yeah. All right, so these are the steps that you need to follow. Now we go to the first step that we need to execute. That is we have to import the libraries and then define the environmental variables. So how do I do it? What I do is, what you do is, since you are the beginner, since I'm also the beginner, all right, so for this case what we have to do is we have to just copy this code and execute from that particular code pane. You see there is a one small long box. So what I do is I copy paste my code here. All right, you see the same code is been copy pasted here, and there is a button called run. Okay, so you come here and just run it. All right, so that's also, once you click on the button run, automatically from the backend this Jupyter instance, or this notebook instance which has the Jupyter kind of libraries or kind of web applications been installed. Okay, so that will help us to import all the required libraries, and that is what we did in a step 1. Yeah. And here you go, it eventually shows the output at the end of the particular box. Okay, so here we paste the code and we click on the button run. it will take certain its own runtime, and once the run is successful, you see the message, success message has been printed out. Nothing but this is the message. Okay, eventually nothing but we are running the Python code line after the line, I can say. Yeah. All right, now we imported the required libraries and environmental variables. Now we go to the next step. So in the next step, what we need to do is we need to create an S3 bucket to save the data. Okay, so in the sense we will be using the S3 bucket to save our machine learning data store in the sense. Okay, so here when I say machine learning model, in the sense it will eventually consume the pre-created data. In the sense machine learning is always like a kind of a kind of a mechanism through which if you are processing a certain historic data, eventually it will tell like what will happen in the future. That is what machine learning model does. For that case, what we do is there should be some storage, right, which can store our historic data. Yeah, and this is the place where we are storing the machine learning data. That is our S3 bucket. So let me copy this code and just put it here. All right, so what it does is if I run this code, it will eventually create an S3 bucket in my this AWS account, and in the location, same location, nothing but EU West location. Yeah. All right, so now let me run this code. It will eventually create S3 bucket. You see there is an S3 error. In this error occurred, you see, when calling the create bucket, and this is unspecified locations constraint. Yeah, you see the reason, right? EU West one. So if I go to the EU West one, EU West -1. So let me see what is the wrong I did. So my region equal to EU West 1. Okay, so here okay, so my region EU West 1. Okay, so it's telling the S3 an error occurred in illegal character. Okay, so let me see what is the illegal character. Yeah, so let me correct this. We need to give the reason name correctly. So what is the reason? So we are created in a EU West 1. So this is EU West 1. So let me type EU West 1. So EU hyphen West hyphen 1. Yeah, and let's run this code. Yeah, so since you see when you select this particular box, you see there is a selection. You see there is an outer box. In the sense you are running that piece of code now. That means, okay, so it says there is a illegal. Okay, so you see there is a illegal, in the sense probably let me change the name. S3 bucket, my reason, create S3 bucket. So let me give some characters. Let me run this. See, error occurred while illegal location constraint exceptions. Okay, all right, so let me run this. When calling the creation bucket, the unspecified location constraint is compatible for the region specific endpoints. Okay, so let me create in some other region. So let's create it in some other region, not in this region, but some other region. So let me use US East 1. Yeah, US East 1. Okay, so let me use this bucket because bucket can be in any region. Yeah, so let me create it. I need to select this code and run this piece of code. You see S3 bucket is created now. Earlier we were using some other reason, probably in that reason this name was probably not available, and that's the reason this bucket was not getting created. But anyways, now our required bucket is up and running fine. You see S3 bucket is created successfully. If you run this again, it will fail because the bucket is already there. Yeah, so don't do that. So run this piece of code only one time, as been suggested in this video. All right, we go to the next step. In the next step, we are still in the process. Okay, we are still in the step called prepare the data of your machine learning model. So now next one is download the data to our SageMaker instance and load the data into the data frame. Okay, so how we are doing? We have to copy this code and run it. Yeah. So before I run this code, let me quickly walk you through this one. Here, we are using the URL lib request method, and after that URL retrieve. And here we are giving big URL. Okay, you see there's a big URL, and in this one we are retrieving bank clean.csv. Anyways, this model is being written for a bank purpose, in the sense evaluating a bank product. Yeah, and finally it will tell like successfully uploaded or not, if there are some errors. Okay, that's what it tells. And finally it will read the CSV and it will tell like data also reloaded. Okay, so that's what we are doing. We are downloading an example CSV file which is there in some other location into the SageMaker instance, and that the data present in that particular CSV file is getting read. Okay, that is what this step does. So let me copy this and I will go ahead and run this code in the next code pane. Yeah. All right, so what I do is I go here and I click on run. Yeah, here you go, the CSV file. Okay, bank clean.csv file is already downloaded, and data is also loaded in our in the SageMaker instance. Okay, that is a second step we did. Next, okay, Now what we did is, we created S3 bucket, we downloaded the, our historic data. That's what I said, I said a word called historic data. In the sense, we have a very huge, data bank. We leverage that data knowledge. In the sense, we leverage the data is nothing but knowledge, right? So we leverage that knowledge. We fed that knowledge into our machine learning algorithm, and that algorithm helps us to predict, like, how that particular bank product, works in when it real time it is being released in the market. Yeah. All right, we go to the next one. The next step is, we will shuffle this data, split the data in the form of, two chunks. Okay. So when you say data in the sense, probably you might get confused. So when I say data in the sense, I will just open the CSV file and I will help you to, grab kind of a knowledge. In the sense, this CSV contains some data, I will tell you. So that kind of data will be, downloaded, for this particular purpose. Yeah. All right, while it is opening, we'll go to the next steps. Since the file is very big, it is taking some time. Yeah. All right, so this is a very big file and it is taking much time as well. So now before I go for the next step, I just want to help you to, grab the, what is the data, what is the, what is the data that contains. You see, it contains some, some very very fine grained numbers and all, and these numbers will be used by our machine learning, model, and it will help us to, predict the, how our data, how our product, behaves. All right, so that is what it happens when you say, when you are looking at this step. Yeah. Now we go to the next step, that is, splitting the data in the form of two format. One is, training data, another one is test data. Yeah. For example, you have 100 line of data, for example. Now in that 100 line, we keep 70% of data for training data purpose and the 30% data for testing purpose. Okay. And that is what, this code does. Okay. I will just walk you through this code as well while I run in this. All right, so you see, we are having two variables, train data and test data. We are doing NP, right? If I go back, NP, right? If I go to the NP, you see NP is nothing but what? It's a number pi, yeah? It's a number pi module. So from the number pi model, I'm using the split function with a certain parameters. Okay, you see these are the parameters. We have the model samples, and we are breaking that data into two chunks. One is train data and another one is the test data. All right, to do that, I will again run this chunk independently. So I will run this chunk. You see, the code has been, you see the code, the lines has been divided into three chunks. One is 70% plus 30%. So this is the training data, and this is a okay. So this is the training data, and this is a kind of a evaluation data, I can say. So that's if you see here. Where were we? So we were here. Yeah, I'll go back to here. So one is the training data, other one is the test data. Yeah, probably, training is something like, we are, making the machine learning to learn it. That is what training does. Whereas test data is once you have trained your machine learning model, you fed some data. That data we call it as a test data. And when you give some test data, eventually it will give some result. Okay, that is what we call it as a output of the machine learning model. All right, we go to the next step. So we are in the stage 3. So stage 3, in step 3, what we do is we train the model. Okay, now, so here we have not yet done the training of our model. We just downloaded the data, we divided the data into two big chunks. One is the training data, other one is the test data. Now we leverage the training data to train our machine learning model. And this is the code which does that. All right, so for that case, what I have to do is I have to run these three chunks. You see there is a star mark. Okay, so you have to run these hash chunks. You see the code chunks which is starting with the hash mark. You have to run it independently. Okay, for your case, for your information. Yeah. First one, use your training data set to train your machine learning model. So how do? We have to do with using this big code chunk. Okay, I will run this in a separate code box. I call this box as a code box. Okay, code box. Now before I run this code, I will just help you to understand this code. Here again, we are using the PD. What is the PD? If I go above, you see PD is nothing but pandas. Okay, that is a one machine learning model. Okay. Now with the Panda, we are using concat. Okay, and in that concat, we are we have the training data. Okay, then we are giving certain parameters. You see the x-axis, axis 1, axis 2 to CSV. This is the something like code syntax that you need to follow. To help your data to help your machine learning model to get it trained. And after that, we are using the Boto3 session, and we are using the S3 bucket, and we are getting the object from there. And finally, we are uploading the train data as well. Yeah. And finally, S3 input train. Okay, so something we are doing here. Okay, all right. So this is very something which is very very complex Python code, I can say, tell you. Well, if you're a Python developer, probably you will understand this very a very deep manner. All right, but always, okay. So to become a machine learning developer, you have to have a good you know Python coding skills as well, I can say. Yeah. So now what I do is I run this code. Eventually it has done its job, and yes, we are now ready for the next step. Okay, so here we use a training data set and we trained our model. Okay, now we go to the next step. Okay, next one, set up the Amazon SageMaker session, create an EC2 instance, sorry, create an instance of XGBoost model, that is an estimator, and define a model's hyperparameter. Okay, so that is the next step that we need to follow. So for that case, we are using the SageMaker session, and we are creating a XGBoost model instance, and we are defining the model's hyperparameter as well. Yeah. So we are creating a XGBoost instance, which is nothing but we call it as an estimator. Yeah. And then finally we are setting we are defining the model's hyperparameters as well. Yeah. All right, so we will just copy this code and we will execute it. Yeah, these are bit very complex code. Probably if I explain, you might get confused. Okay, that's the reason I'm just going ahead and just walking you through, so that you will get a glimpse of how does a SageMaker module works. Yeah. All right, so what we do is we go here and we run this code. All right, so that's also been done. Now we go to the next step, that is start training. So here we create, so here what we did is, in layman term, we created an instance of type XGBoost model. Then we are defining our parameter. Now once all been set, next been we are initiating training job in the sense, inside this particular XGBoost instance, we are invoking certain job, yeah, which will eventually help us to help your module to get it trained. And that is where we are doing, right? So this is code does that. So let me run this. All right, so now this training job is much time consuming. It will take some certain time. Okay, we have to wait for that, but eventually we can go for the next one. Yeah. All right, so if I go here, so the starting the training job. Okay, while it is been running, let's wait for certain time. And what we do is we have, okay, we just scan our eyes through the above code. Okay, so here we are using the SageMaker. Inside the SageMaker, we are using the session, and the session is been stored here in this variable. And after this, okay, you see the session variable. So you see again inside the SageMaker, you see we are using the estimator, and inside the estimator we are using the again capsulator estimator. Okay, both are different functions. Yeah, and inside this we are giving the parameters. Okay, you see the parameters are being passed, and the parameters are which includes XGBoost instance row instance, the role which we created, then instance count, then instance type. You see ML M4 extra large. Okay, which is an extraordinary machine, I can say. Yeah, and output paths. Okay, the output path will be our S3 bucket. Okay, you see, and the format. Okay, you see the output path. Okay, so the output path is something like our S3 bucket, and the format of the bucket name, prefix, and SageMaker session. Okay, you see the session is being consumed here. Yeah, and that is what it happens here. And next one, in the XGBoost, in the sense this is a kind of a object here. Inside the object, we are doing a set hyperparameters. You see in the hyperparameters, we are setting certain parameters. That is maximum depth equal to 5, ET equal to 0.2, gamma equal to 4, minimum child weight equal to 6, subsample equal to 0.8, silent equal to 0, object something like. So these are the parameters which are meant for invoking the set hyperparameter function. Yeah. And finally, with using the XGBoost parameter or the object, we are invoking fit dot function, which fit function is nothing but it's a training function. Okay, where train equal to, we are giving the where the train data is nothing but train data is been fitting train data is now sitting in the S3 bucket, and from there this XGBoost instance pull that data and does the training job. Okay, that is what it is happening in the train the machine learning model. Okay. All right, so I have walked you through this this code as well. So now we are at step 4, that is deploying the model. Now we have trained our model. Now we have to deploy that model so that we can use that model to do a evaluation at real time. Yeah. All right, so now it is preparing the instance preparation. Okay, so eventually this is a time consuming job, because it has to launch the instance, it has to prepare the instance, and it has to start the training, and finally it has to download the it has download the input. Once once the input is been downloading input is nothing but our input is sitting in a Amazon S3 bucket. Yeah, so if I while it is been running, I will just walk you through the S3 bucket and I will show you. And here you go. So if I go to the S3 bucket, so we are in the SageMaker pane, so I will go to the S3 bucket. And in the S3 bucket, I will show you our bucket name. Yeah. All right. So what was our bucket name? So if I go above, so we were here, right? So this is my bucket name in the US East one. Yeah. All right. So I go here, I go somewhere here, search that bucket, and here is the bucket being created. Okay, I have not created that bucket, but it has been automatically created by Python code. Yeah. And inside you see that there are certain folders have been created. Inside the folders, now we should be seeing something like demo XGBoost demo, and inside that we have the training and training data and output data. Yeah. So in train data is nothing but the data which I opened in a CSV file. Okay, that is a training data. Yeah. And in output, in the sense output is nothing but what happened after the training. So that is what output data will be stored in this folder. Yeah. All right, so now our that instance is utilizing this S3 bucket and doing all the operations. Okay, that's what I can tell you. And here you go. Right, so you see at the end, you see the training job is completed. That's what you have to wait. Okay, so till this stage you have to wait. Okay. All right, so now training is completed. In the sense we have fed some example data and your model got trained. All right. Okay, now we go to the next steps. All right, so let me scroll it down. Next step is we have to deploy the model. Okay, so now deploy a model to a server, create a SageMaker endpoint that you can access. This step may take few minutes. Okay, and now I'm telling you forefront that this step is a very time consuming step. Okay, so here let's run this code, and that will deploy the model. All right, so let me run this code, and let's run this. Eventually this step will take certain time. Yeah, you see there are certain hyphen output is getting created. Yeah, while that completes, I will just help you to understand what we are doing here in the Python code. So here we are using the XGBoost. You see we are using this object, that is a SageMaker object, and we are deploying our model, that is a SageMaker machine learning model. And the initial count, instance count equal to this 1. In the sense we are deploying this model on an instance of count 1, and instance type is something like ml.m4.xls. Okay, which is a very a pre-configured an image which is dedicated for doing a machine learning jobs. Yeah, and that is what it happens here. Yeah. Okay, so all right, so this is where instance gets created, and finally to predict whether the customers in the test data enrolled for the bank or not. Okay, all right, so here what we are doing is we are so here what we did is we deploying our machine learning model on a server, and we are also creating a SageMaker endpoint that can help you to access. Okay, so what we are doing is we are building a server, creating a SageMaker endpoint, and that endpoint will be consumed in the down the line. Okay, that is a simple term that you can try to understand. All right, so now it takes certain times. You see there is a certain hyphen outputs are being printed here. Finally we should see some exclamatory mark. Okay, when we see some exclamatory mark, that indicates that instance is been up and running fine, and your machine learning models endpoint is up and running fine. Yeah. All right, so let's wait for that to get completed, then we can go for the next step, that is to predict. In the sense the next step is once the your model is deployed, then it is time to consume that model in the consume that model in the sense SageMaker endpoint, and try to use our test data and see the results. Yeah, so that's what it does to predict whether the customers in the test data enrolled for a bank product or not. In the sense that is what I said in the first. Okay, what I said, here we are building a machine learning model which is meant for a bank, where bank is now releasing certain product, and we are using certain historic data, and with using that historic data, this model will be run on that historic data, and we are predicting like how does this product will behave in the market. Yeah. All right, so let's wait for this deployment gets completed. So here this currently what we are doing is we are deploying our machine learning model. All right, and after that we have to start our predictions. Okay, that is a real-time predictions. All right. Okay, and you see, so before that while that code gets completed, let me walk you through the next steps. So in the next step what we are doing is this is a big code. Okay, so for your guess, okay, for your information, you have to run this complete piece of code. Okay, not like that. So let me say this correctly. So you have to copy this code and run in the next. So what actually this code is done in the sense we are using the SageMaker.serializers, importing the CSV serializers, test data. So in the test data, as I said, we have divided the data into three chunks. Okay, one is the 70% for training purpose, 30% for real-time testing purpose, in the sense post deployment of the model. All right. So here test data. Okay, test data drop. Something like we are retrieving the test data. All right. So after that, XZ predictors. Okay, XZ predictor is nothing but that is an endpoint. That is a SageMaker endpoint. And in that one, we are using the serializer function and okay, set the serializer types. Okay, that is the CSU serializers. And after that, in the predictions, we are using the XZ boost, XZB. Okay, nothing but XZ boost predictor. Predict a test array. So the test array is nothing but the data which is a test data. And in that one, we are decoding into UTF format. Yeah, that is nothing but predicting. It does actually predicts. And the prediction array. So you see in the prediction array, we are using the NP format the strings prediction 1. Okay, and turn the prediction into an array. In the sense, it will just give an output. Okay, and that is where the output tells about. Yeah. All right. So let's see if the deployment completed. Here you go. When you see an exclamatory mark here in the output, that means that the model deployment got successful. Where model is deployed an instance of type something like this. Yeah, and count is of instance is only 1. Now what we do is now we leverage that SageMaker endpoint. And what we do is we evaluate that, in the sense, in generally not evaluation, we now use the real-time test data and consume that endpoint to see how our model behaves on that data. Yeah. All right. So let me do that. What does this actually does is, in the sense, it will consume our test data and pass that test data into this model and gives the result, like what will be this prediction will be from this machine learning model. All right. So that was very quick. You see, it has predicted something. Okay. All right. We are good now. Okay. So now we have deployed our model into the Amazon SageMaker endpoint. Now the time is that now we are at the stage of fifth stage. In this fifth stage, what we did is, see, we deployed. Now we deployed our machine learning model. Now it is time to evaluate. In the sense, it has given certain output. So when you deployed a model, we also fed some certain test data, and test data gave some certain output. Now with using that output and with using the real-time market output, what we do is we do a evaluation. Okay, and that is what this step does. Okay, so here evaluate the performance and accuracy of machine learning model which we build above. This code compares the actual versus predicted values in the table, and we call it as a confusion matrix. Yeah. All right. So now what I do is I just have to copy this code and run this. Okay. Before I run this, it's a big, pretty complex code. Okay, but let me help you to understand. So here we're using the pandas object, and this one we are using the cross tab. Okay, so in the cross tab we are giving certain parameters. One is the indexed test data, and we have the round off values. We have the row names observed. Then we have the columns predicted. Yeah, and with using the CM again, we are using the something. We are doing a a kind of a mathematical operations and comparing between the actual and versus predicted values. And finally, the output will be given here. Okay. All right. So let me copy this code and run it. Yeah. And this will eventually tells us the result of our model. Yeah. So here again. So till now you might have been observed what I'm doing. I'm doing nothing, but I'm just copy pasting the each chunk of the codes of this particular Python file and keep on running and also explaining. Yeah. All right. So here you go. It has successfully given the particular rating out of, in the sense it has given the evaluation. Okay. All right. So here evaluation model performance, in the sense the performance of our model has been given. You see the overall classification rate is 89%. Okay. That is what it tells. In the sense it is telling that our machine learning model has predicted the performance of the a bank's product in the market at least 90%. Okay, if I round off 89 but 89.50%, in the sense I'm rounding it to 90%, in the sense this machine learning model helped a bank to predict that this particular product will behave in certain way, at least 90% correct. Okay, and I believe that 90% correctly prediction is extensively great, I can say. Yeah. All right. So once you are know that once you know that how does your business, in the sense how does your product or how does your service can behave in the market at the accuracy of 90%, in the sense, you'll see how much this machine learning model has the capacity to save the problems that can occur, or the advantages, or the kind of profit or kind of losses can occur. Okay, so all this data can be gathered from our machine learning model. All right, so we have came at the end of this module. Okay, so I have successfully shown you, everything that I need to show here from the scratch to end. Okay, from the scratch, when I say from the scratch, in the sense I have showed you, like, how you can create an Amazon SageMaker notebook instance, and after that, with using that SageMaker notebook instance, how to prepare a data. Okay, how to prepare the data for machine learning module. Then we also seen, like, how to train the machine learning model, how to deploy the same machine learning model, and finally how to put some test data into that model and see the how does that model gives the output. Now, based on that output, what we did is we did an evaluation as well. So not only we just see the predictions, we are also evaluating that prediction with the real-time market, real-time data, in the sense predicting data versus actual data. And at the end, we also came to know that this model is accurately telling at least 90% accurate prediction is done by this machine learning model. Yeah. All right, so that's all for now. Thank you very much for watching my videos. Kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, thank you. Thanks a lot.